Hello everyone, I am Lavesh Vyas and I am from CS2 third year. Today we will learn about an exploration of animation methods. Goals of this presentation are defining key animation techniques used historically and today, explore how animation is applied in film, gaming and simulations, comparing mutual traditional and automated digital AI animation, discussing about advantages and limitations of each technique, proving real-world examples, examining further trends and advancements in animation technology. Objective of this presentation is to understand fundamental animation types, traditional keyframing, procedural behavior, motion capture and physical based. Introduction to animation. Define. First, what is animation? Animation is the technique of creating the illusion of movement by displaying a series of static images in rapid succession. Historical origin. It started with flipbooks and hand-drawn cells in early 1900s. Evolution from 2D hand-drawn frames to 3D computer-generated imaginary CGI and then AI-assisted animations. Early animation versus modern animation. In early animation, the technique was hand-drawn frames with cell animation. In modern animation, it has CGI, AI-driven simulation, and digital tools. The tools are pencil, paper, and cells in early animation, while in modern animation, the tools are software like Blender, Maya, and Caps. Introduction to animation. So it's already been told. Now we have traditional animation image, which is frame by frame, how it looks like. Then process of traditional animation. Step 1, storyboard. Storyboard creation to outline the story and key scenes. Step 2, draw key poses. Step 3, fill in between the frames, also called twinning. Step 4, clean up drawing and finalize lines. Step 5, coloring and shading each frame by hand. Step 6, layering backgrounds and foregrounds for depth. Step 7, filming frames in sequence to create motion. Applications of traditional animation. Classic Disney movies, Snow White, Cinderella, The Lion King, early Warner Bros. Movies, cartoons, Looney Tunes, Merry Melodies. Educational animation and flip books for learning, used in some modern films for styling flashbacks or special sequence. Example is Studio Ghibli hand-drawn animation style in films like Neighbor Totoro. Now there are some limitations of traditional animation. It requires large team of skilled artists for featuring length films. It is actually very time consuming, drawing thousands of frames, difficult to make changes or correctness, high production cost, long timelines, labor intensive, physically demanding. Now what is keyframing? Keyframing involves setting important frames manually and the computer generates the frame in between. It is a common in 3D animation and CGI films. Examples are characters jumping or waving animated by setting a start and keyframes. This is the diagramic view of keyframes or keyframing animation. How keyframe works? Keyframe basically animator sets key poses at specific times on a timeline. Software calculates in between frames using interpolation and algorithm. It allows easy tweaking of timing and motion curves, can be combined with motion paths and constraints. Then application in films and games, used in blockbuster CGI films like Pixar Toys Story and Marvel's Avengers, character animation in video games like The Last of Us and Fortnite, software examples like Blender, Maya, Adobe and After Effects. Advantages of keyframing. It saves time compared to drawing. Every frame provides precise control over key moments in animation, allows easy modification and retiming, supports complex animation, compatible with motion capture data for hybrid animation. Now the limitations of keyframing, it requires the skills animators to create nature looking process. It also interpolate frames can appear unnatural or robotic. Then there is complex motions may need many keyframes, increasing workload, and it is also less suitable for highly dynamic and unpredictable. This is how a procedural animation looks. Now, what is procedural animation? Animation generated algorithmically, often using mathematical models or AI, known as procedural animation, common in simulations and real-time applications. For example, flowing water, fire, or crowd movement. Process of procedural animation. It defines rules, physical parameters, it uses algorithms to simulate motion. AI can drive behaviors, real-time calculation can be the combined with keyframing for hybrid effects. Procedural versus hand-drawn animation. In procedural animation, we require algorithmic simulation, while in hand-drawn animation, manual drawing frame by frame. It is dynamic, environment responsive, while hand-drawn animation was fixed ones drawn. About control, procedural animation have less direct control, while hand-drawn animation have full artistic control. Behavioral animation. Behavioral animation is a technique where characters or objects move autonomously based on AI-driven decision making rather than predefined keyframes. Animators define rules, goals, or behavior instead of explicit movements, used to simulate intelligent life-like behavior in characters. Example includes NPC in open world games exhibiting natural responses. AI integration in behavioral animation. So characters can play parts and enables emergent behaviors. AI-driven animation can reduce the need for manual keyframing. Now talking about motion capture animation. Motion capture mocap records real human or animal movements using sensors or cameras. The captured data is mapped onto digital characters, models to create realistic animations. Capture subtle nuances like facial expression, finger movements, and body language. Examples like films like Avatar, The Lord of Rings, or games like FIFA. This is a motion capture animation. Now, physics-based animation. Physics-based animation simulates real-world physical laws like gravity, collision, friction. Objects behave naturally based on forces and constraints applied in the simulation. Used for animation, rigid bodies, soft bodies, fluid clothes, and particles. Example like falling object, bouncing balls, cloth fluttering in the wind. How physics-based animation works. Define physical properties like mass, velocity, elasticity, friction. Apply forces such as gravity, wind, or user input. Results are rendered as a smooth animation integrated with other animation techniques. Applications of physical-based animation. Realistic destruction effects, fluid simulation for water, smoke, cloth and hair movement, vehicle and object dynamics in racing and simulation games. Virtual reality environment. Future trends in animation, increase integration of AI and machine learning for smart animation generation, real-time animation and rendering with ray tracing and advanced shaders, more accessible motion capture via affordable devices, use of virtual production, growth of procedural and behavioral animation, expansion of interactive and immersive animation via VR. Now, last but not the least, summary. Animation is a versatile art form that brings static visuals to life, transforming storytelling, education, marketing, entertainment. Core techniques explored: traditional hand-drawn, keyframing, procedural, behavioral, motion capture, physical-based, modern animation. At the end, summary. Each technique has unique strengths and ideas. Traditional and keyframing excel in creative control and stylization. Motion capture and physical-based animation deliver realism and efficiency. Key takeaways: mastery of diverse animation technique empowers creators to communicate complex ideas. So, thank you.